Consider negative resonance effect or minus R effect. This effect is observed when the transfer of electrons is towards the atom or substituent group attached to the conjugated system. For example, nitrobenzene is given. In nitrobenzene, when we see the different structures, we will come to know that polarity is produced in the molecule. Oxygen end is negative and one of the carbon atoms present with the benzene ring carries a positive charge. Thus, polarity is produced in the molecule by the interaction of two pi bonds. NO double bond has one sigma bond and one pi bond. So, by the interaction of the pi bond with the NO and one of the pi bonds present in benzene ring, a polarity is produced in the molecule. Now, consider the first structure given. NO bond is polar, so shifting of electrons will be towards the oxygen atom. When the pi electrons get shifted to oxygen atom, there will be simultaneous shifting of pi electrons present in benzene ring, and the carbon-nitrogen bond will now acquire a double bond character. Now consider the second structure. The resulting structure is given here. At the ortho corner, we can see that a positive charge is developed and oxygen end carries a negative charge. Thus, polarity is produced in the molecule by the interaction of two pi bonds. Now, in order to cancel the positive charge which is present at the ortho position, the pi electrons present in the benzene ring will get shifted and thereby a double bond will be created and the para position will now become positively charged. Now, in order to cancel that positive charge which is developed at the para position, the pi electrons will shift, a bond will be created there, and the ortho corner will now develop a positive charge. So, from these resonating structures, it is clear that polarity is produced by the interaction of two pi bonds, and the transfer of electrons is towards the atom or substituent group attached to the conjugated system. So, this is known as negative resonance effect or minus R effect. The atoms or the groups which show plus R effect are halogens, OH group, OR, OCOR, NH2, NHR, NR2, NHCOR. Now, the groups or atoms which show minus R effect are carboxylic acid group COH, aldehyde group CHO, carbonyl group CO, CN, NO2. Electromeric effect or E effect. It is a temporary effect. The organic compounds having a multiple bond, that is double bond or triple bond, show this effect in the presence of an attacking reagent only. Now, how can we define electromeric effect? It is defined as the complete transfer of a shared pair of pi electrons to one of the atoms joined by a multiple bond on the demand of an attacking reagent. The effect is annulled as soon as the attacking reagent is removed from the domain of the reaction. It is represented by E, and the shifting of the electrons is shown by a curved arrow. There are two distinct types of electromeric effect. So, electromeric effect is a temporary effect and it is shown by compounds having either double bond or triple bond, and this effect is shown only in the presence of an attacking reagent. And in this effect, there will be complete transfer of a shared pair of pi electrons to one of the atoms joined by a multiple bond. Positive electromeric effect or plus E effect. In this effect, the pi electrons of the multiple bond are transferred to that atom to which the reagent gets attached. For example, consider the carbon-carbon double bond which is present in alkanes. In the presence of attacking reagent, that is H+, there will be transfer of pi electrons to one of the carbon atoms, and we find that the attacking reagent also gets attached to the same carbon atom. The other carbon atom, since it is electron deficient, will now develop a positive charge. Next, consider negative electromeric effect, minus E effect. In this effect, the pi electrons of the multiple bond are transferred to that atom to which the attacking reagent does not get attached. For example, again consider the carbon-carbon double bond which is present in alkenes. Now here in the presence of attacking reagent, that is Cn minus, we find that pi electrons get shifted to one carbon atom and the attacking reagent gets attached to the other carbon atom. So this is known as negative electromeric effect. Here the pi electrons are transferred to that atom to which the attacking reagent does not get attached.